Okay, this is going to be the Quadratics Chapter 5 review for 2014. I'm going to show factoring through the area model or the boxes, which many people like to refer to it. Okay, I want to go over something real quick before we get into that because I think it's very important to understand where we're going. All right, the words roots, zeros, solutions, x-intercepts, they all mean the same thing, okay? And oftentimes, they're going to be written like something like this, okay? Factors, and then equation, okay? Now, to convert these to factors, what you basically do is you change the sign, okay, for both of them. Okay, so you're changing sign. All right. Anything with a fraction underneath it, or denominator, move that up. So I got x plus 2, 3x minus 4. Okay? So that's one thing. To get to the equation part of it, you multiply those factors. And you guys should be all good at doing this now. Okay? Okay? So if they ask you for the equation, if they're given this, you got to go to the factors and the factors to the equation. If they give you the factors in the equation, that's pretty easy. Jump from one to the other. Okay? Now, if you're given the factors, let's say 2x plus 5 and x minus 7. Okay? And you got to get back to these. Okay? All right, what you do is you basically change the sign, put an equal sign. Okay, so the plus goes away, I change it to a minus, and then I solve by dividing by 2. It's a really quick shortcut. Okay, that one's easy down there, okay, because that's going to go and become that. Okay, all right, so if you're starting with an equation and you're working your way backwards, you have to factor. If you're starting here, working back here, you want to go to the factors first. That's where you have to stop at first, and then go to the roots. But these words all mean the same thing. Okay, let's get back to our example. So it says factor completely. So all I want me to do is stop at factoring. Okay, so this is a difference of squares. So what you can do here is you can take the square root. Okay, I'm going to check for GCFs. There's nothing in common there. No variables, no numbers. Okay, if I take the square root of that, that's 4x. Square root of 25 is 5. Now, if you notice, there's two parts to the area model. So I got 16x squared and negative 25. So the shortcut here is this is going to be 4x. All right, that's going to be 20. Okay, that's going to be negative 20x. Okay, that's going to be negative 5. So what you notice is it's the same thing, except you have a minus between them. Make sure you have two terms. Let the area model verify that for you. These first couple questions, we're all going to do this without the calculator. Okay, this one, there's no variables in common, no numbers in common. So what I got to do here is I got 2x squared and 6. Okay, so I'm going to multiply that, I get 12. Now, what I want to do is I want to pick a combination that multiplies to get me 12, and then we'll add across to equal my middle term. So the combination there is negative 3 and negative 4, because that times that would give me that. If I add that up, I'd get negative 7. So I got negative 4x, negative 3x. Taking the GCF going across, that's going to be x. And you can keep taking the GCFs. Couple rules of thumb. If there's a minus here, you got to put a minus. Okay, if it's the box right next to it, you got to put a minus. This would be 2. Okay, this would be 3. Okay, all right, and the thing in common there is 2x. And you can unravel it that way. They're GCFs all the way through. Okay. Or you can find the first one and use logic to come up with the rest. So the factoring there is 2x minus 3, x minus 2. Okay? Moving on to this one. Okay? All right, nothing I can take out. Okay, I got x squared and 64. Okay? I want a set that multiplies to 64 that would add to 16, which would be 8 and 8. Okay? So that's GCF. All right? Is that is that. Okay, all right, that is that. All right, so you can always check it. X times x is x squared, 8 times x is 8x, x times 8 is 8x, 8 times 8 is 64. So what I got is x plus 8, x plus 8. Okay? Now on this one, there is something in common here. It is an x. So what I want to do is I want to put that down with my answer, and I'm going to take out x, and what I'm going to have left over is x squared minus 1x minus 12. Okay? All right? I want to come up with a set, there's a 1 here, that would multiply to negative 12, add to negative 1. That set is negative 4x and 3. So there's an x here, there's a minus, so negative 4, there's an x. Now, the minus is down here, but since this is the box, I'm going to leave that positive, which would be 3. So I got x minus 4 and x plus 3. Okay? And there's my answer there. Okay? Moving on to this problem here. All right, 4 boxes. What's nice is when you got the 4 terms, if you just follow this order, all right, if you follow that order, 1, 2, 3, 4, it works out. So going across, the only thing I got is A, okay? All right, going across, the only thing I got is 3, okay? All right, GCF there is 7, and A times 7 is 7A, 7 times 3 is 21, so I'm good there. Okay, the thing here would be 3x. A times 3x, yep, that gives me that, right? So it's a plus 3, 7 plus 3x, okay? All right, on this one, there's a common number here, so I'm going to take out that 3, put it down here with my answer. So what I got is x squared plus 6x plus 8, okay? Once again, I'm going to go ahead and use the boxes for that, x squared and 8. So I'm looking for the set, there's a 1 here, that's going to multiply to 8, but add up to that. So it'd be 4 and 2. So it's x and 4, x and 2. So x plus 4, x plus 2, and we're done. Okay? All right, now, this says the quadratic zeros are negative 2 and 5. What's the equation? So once again, zeros to factors, factors to equation. Okay? So I got to convert these to factors. So first they're going to turn into x plus 2, x minus 2. Okay, I've stopped there. Now to get to the equation, all right, I'm just using the boxes now. X and 2, x and negative 5, so that's going to be x squared, 2x, negative 5x, negative 10. So what I got is x squared minus 3x minus 10. Okay, combining 2 minus 5. Okay, sketch the possible quadratic. Now, with the pictures, negative 2, okay, that's the same thing as x-intercepts. So I'm going to go ahead and put that 1, 2, 3, 4, and 5. And I'm just going to go ahead and draw a quadratic that passes through those points. Okay? All right. Using factor, give all the solutions. Okay. So solutions. Once again, how am I going to travel here? I've got solutions, factors, equation. So what I'm going to have to do, I'm starting with the equation, so I'm going to have to work my way back to the factors and then to the solutions. Now, what you want to make sure of is everything's on the same side. So if that's 6 on this side, okay, what that's going to be is 7x squared plus 19x minus 6. Okay? All right, so when I go to factor that, okay, I got 7x squared, all right, negative 6, okay? So 7 times 6 is negative 42, all right? So I'm looking for the set that's going to give me 19. Well, that's going to actually be pretty simple. That's negative 2 and 21. Negative 2x and 21x, okay? Going across there, that's 7x. Going across there, it's negative 2. That's x. That's going to end up being, if you get confused with that, 7x times that's going to give you that, so that's 3, okay? Now, so what my factors are 7x minus 2, okay, and x plus 3. But I don't want to stop at factors. I want to go to the solutions. So what that's going to be is 7x equals 2, x equals 2 sevenths, because you basically divide by 7. All right, this is just going to be pretty easy. X equals negative 3, and I'm done. So I wanted all the solutions, okay, so I stopped at factors, then I went to that. Okay, this one, I got to move the 10x over, so I got 15x squared minus 10x. Now, should try to take a GCF, okay? All right, the GCF there is going to be 5x, so it's going to be left over is 3x minus 2. And I can't factor that anymore because there's no squared there. So what this is going to convert to is 3x equals 0, and I'm going to divide by 5, I got x equals 0. This is going to be 3x equals 2. Divide by 3, I get x equals 2/3. Okay? This one, all right, is already equal to 0. Okay? So I'm going to go ahead and factor that because there's no GCF, no variables in common, no numbers in common. 3n squared and negative 2. So if I multiply that, I got negative 6. So I'm looking for the set that multiplies to negative 6, adds to 5. Okay, so I think that's 6 and negative 1. Yep, that fulfills my criteria. Okay, so that's going to be 2. That's going to be n. All right, that's going to be 3n. And that's going to be negative 1. Once again, you can always check it by multiplying these things. All right, it confirms what you have. So I got 3n minus 1. Okay, and n plus 2. So I don't want to stay at the factors. I want to turn those factors into zeros. That's 1/3. That's going to do a simple change to negative 2. Okay? D squared equals 64. Once again, I move that 64 back over. I got d squared minus 64 equals 0. Okay? So I want to take the square roots of those. So that's going to be d plus 8. Okay? All right, if I'm doing the boxes. All right? So that's going to be d minus 8 on that side. Okay? All right? We move that up a little bit. Okay? So what I got is d plus 8 and d minus 8. So that's pretty simple. D equals negative 8 and d equals 8. Okay? Those are my solutions there. Okay. All right. This is the last question that you will be expected to be able to do without a calculator. All right. So it says find, solve. So that's another word for solutions. So I'm starting here. I need to factor. So what I'm going to do is I'm going to take out my 2. Okay. Actually, let's solve by square roots. Okay. This might be a little bit easier. Okay. I'm going to move that over. That's 2y squared equals 48. I'm going to divide by 2. That's y squared equals 24. Okay? And square root plus and minus. Okay? And what I want to do is I want to break down 24. All right? So 24 broken down, 2 and 12, 2 and 6, 2 and 3. Okay, there's my pair. So I'm going to have plus and minus 2, square root of 6 would be my answer. Okay? So you have to be able to use those things right there without a calculator. Now, I'm going to pull up my calculator to do the rest of this. Let me erase this a little bit. Okay? All right, to do this. Now, a good rule of thumb, if you have the tool for the calculator, get everything on one side. Okay? So if that moves over, that's going to be a negative 35. All right? So if I need to use my calculator for that, okay, I'm going to do negative 1 minus 35. So that's going to turn into negative 36. So what I got is x minus 5 squared minus 36 equals 0. Okay? Now, a couple things I want to make sure my calculator is set up in. Since we're doing a lot with quadratics, I'm going to do a shift menu. I'm going to make sure that that's set up in A plus BI mode. That's one thing I want to do. Okay? So shift menu. Make sure your thing has been turned to A plus BI. Okay? Couple things that you might want to look at. There's two ways to basically solve quadratics with your calculator. One way is if you have everything, oops, oh, hold on. Okay, oops, the wrong thing. All right, so if you are at equa, and you want to go to equa, go to polynomial. And these are all going to be degree 2s. Now, what you notice about this is it needs to have just a single term, single numbers in front of those. Okay? That's one way to do it. Now, in this case, since I've got this weird thing inside, I can't do that. Now, what I can do is I can go to my graph, and I can graph it. Okay? So what I got is x minus 5 squared minus 36. Okay? Execute. Okay. All right, execute. Let me, hold on, my board's being sort of crazy. Okay, so I'm going to draw. Now, I don't see it. I'm going to do F3, F3, exit, draw. All right, don't see it well, so I'm going to go ahead and zoom out. Whoops, out, enter. Whoops. Zoom out, execute, and now I can see it. And these are my solutions. The way I get those are gsolve, root. All right, one of those is going to be x equals negative 1. Another one Just hit the over button is going to be x equals 11. And that's how simple some of those are. Now, on this one, okay, on this one, since I've got something a little bit nicer, I'm going to go into equal and do this one. Now, when I go to polynomial, which is f2, it's a degree 2, the number a is the number in front of x squared, which is 3. Now, the number in front of x, okay, is 0, because there isn't one. And then this one's 147. Now, when I hit solve, okay, this is a piece of cake. This is easy. 7i and negative 7i. I am finished, okay? So write down your answer. Now, if that was a radical that had a nasty decimal, we'd have to reduce it. But since it's not, always write down your answer to start, okay? All right, okay. One thing to do here that can save you some time, okay? Let's go ahead and find our zeros because it says write it in standard form, okay? Well, here's a simple way to do that. Let's go into graph, okay? Let's go into graph, all right? Let's do 2, all right, x minus 1, all right, squared, all right, plus 7, all right, draw it, okay? F3, exit, draw. Okay, I don't get a lot with that. Now, the way you would handle this, okay, is you would multiply, all right, x negative 1 and x negative 1, okay? So that's x squared, negative 1x, and 1. Now, since there's a 2 outside, all of these double. So that's negative 2, that's 2, negative 2, negative 2, 2, okay? And then what I have here is the 7. So when I combine all my like terms, I get 2x squared minus 4x, 2 and 9, or 2 and 7 becomes 9, okay? And if I wanted to check that, I could always graph it to make sure it's the same graph, okay? And that's 2x squared minus 4x plus 9. Let's see. Same graph, nothing new. All right, I'm going to zoom out so I can see a little better. Zoom out. Okay, same graph, so I'm good. Which of the following is a quadratic expression? That's pretty simple. That's going to be that one. Okay, that's a cubic, that's a linear, that's a square root. Okay, given the graph, write the equation. Okay, once again, we're going to solutions, roots, x-intercepts or zeros, turning them into factors, turning them into an equation. So the first place I got to stop at is factors. So that's 1, 2, 3, 4, 5. That's negative 5 here. That's 2. So to convert those to factors, that's x plus 5, x minus 2. Okay? So I got x equals negative 5 to start, x equals 2. Those were these things. That's this. Now to make the equation, get your box out. So basically your equation is always going to be a box. Whether that box is something you have to use to factor, or that box is something you use to multiply. So what I got for an answer is this, all right? We should be getting pretty comfortable with that. What are the zeros of the quadratic whose graph is given above? That's pretty easy. We've just found that already. X equals negative 5, x equals 2. It's testing your vocabulary, okay? 16, state the discriminant. Now, in order to get the discriminant, once again, I got to move that over, all right? So what I got is 3n squared minus 7n, okay, minus 5, okay? And, all right, in the quadratic formula, A, B, and C, where the quadratic formula is this. Now, all right, what you can do to save yourself a lot of issues, go back into the menu button, okay, and set these up. So I'm going to set 3, arrow, alpha A. Okay, so alpha A, execute. That's saving it as A. Negative 7, alpha B. Oh, whoops. Arrow, alpha B. Okay, it's saving B. And then negative 5, arrow, alpha C. So what that's doing is when I type the quadratic formula, alpha B squared minus 4, alpha A, alpha C, okay, it's going to give me an answer, okay, which is 109. That is my discriminant. The discriminant of a quadratic is 0. Circle that answer. That's going to be 1 root, okay? All right, so here's a good rule of thumb. 0, 1 real, okay? 2, I'm sorry, not 2. If you get a number greater than 1, all right, so above 0, okay? So above 0 is going to be 2 real. Below 0 is going to be 2 imaginary, okay? So these are like negative numbers. These are like positive numbers, okay? Sketch an example of a quadratic of each, okay? Imaginary roots don't cross the x-axis. Okay? It's okay to cross here, but it can't cross here. One root, okay, one real root, like just touches and goes up. Two roots, it crosses clearly twice. Okay? Sketch of an example of the discriminant. Okay? I think we just went over this. What's this going to be? This is going to be 2 real. Okay? So that's pretty simple. That's going to be less, so that's going to be 2 imaginary. The imaginary ones don't touch. Okay? And then 0 is going to be 1 real. So that just touches one spot right there. Okay? Set up the quadratic formula. Do not simplify or solve. Once again, the negative 4's got to move over, so it's going to become positive 4. All right, that goes away. Now, the formula says, and you have the formula in front of you, but I'll rewrite it. Okay? This means opposite of whatever b is. So that's going to be negative 3 plus or minus. Okay? 3 squared minus 4 times 9 times 4. Okay? So a, b, and c all over 2 times 9. Okay? Solved by the quadratic formula. Now, before we come up with a solution there, I'm going to go ahead and figure out what this is in equal. Okay? Here's why. I want to make sure that my answer is right, just like what we did with radicals. We want to make sure that what we get is a right answer. So I got 3, that's going to be negative 1, and that's going to be 8. And I'm going to go ahead and hit solve. Now, here's what this tells me. I've got 1/6 plus something I. 1.62i. The other answer I got, okay, is 1/6 minus 1.62i. So, when I do my radical here, now here's what, I want to make sure that I have an answer with an I and a fraction, okay? So, I'm going to label this A, okay, that's going to be A, B, and C, okay? Now, I'm going to go ahead, and put those in the calculator, all right? I'm going to go ahead and put those in the calculator, just like I did before. So, I'm going to set 3 for alpha A, oops, alpha A. I'm going to set, that's a negative 1, alpha, oops, arrow, alpha B, and 8, arrow, alpha C. I'm going to go ahead and find the discriminant, b squared minus 4, alpha A, alpha C. So what I got there is negative 95. Now, I already know I have to account for my answer, so I'm just going to worry about 95 for right now. Okay? I'm going to see if 95 can break down. All right? I think that's 5 and 19. Both of those are prime numbers, so I can't do much there. So what I got is plus and minus 95. Okay? The opposite of negative 1 would be positive 1. And underneath here is 3 times 2, which is 1 plus or minus square root of 95 over 6. Now, I want to check. I can't do anything because there's really a 1 here. This 1 divided by 6, okay, 1 divided by 6 doesn't reduce for either one. It stays 1 over 6. Now, since my answer had an I can go ahead and put my I. Let me erase this thing right here real quick. Plus or minus. All right, I. You can put one I if you want, or just leave it as I. Once again, if I would like to check that, here's how I do that. 1 plus, okay, option, complex, I, square root of 95. Now figure out the addition part first, divided by 6. And if you notice, that is the answer that I got before, okay? If you copy that, copy that over. And if I do the same thing, 1 minus, because that's what that means, all right, I, square root of 95. Okay, figure out what that is, divided by 6. All right, once again, that is the same answer that I got here, so I know that is correct. Okay? All right, solve with the quadratic formula. Once again, I'm going to come over here, all right, and I'm going to go menu, I'm going to go to equal. I'm typing polynomial, degree 2, 3, 5, negative 2, and I'm going to hit solve. Okay? Now, what I notice about this is that's going to be, my solutions are 2 11s, and if I scroll down to this one, that's negative 1/3. Now, they want you to show the work for full credit for the quadratic formula. But here's the deal. most people make a mistake writing their final answer. So let's go ahead and take a look at this. If I want to use the quadratic formula, I want to do the b squared part first, okay? All right, so I want to do 3 for alpha a, whoops, alpha, whoops, let me go over here, alpha a. Let me go 5, arrow, alpha b. Let me go -2, arrow, alpha c. Okay, then alpha b squared minus 4, alpha a, alpha c. Okay, so I got square root of 49. Okay, square root of 49. Well, that's actually pretty nice. Square root of 49 is, right, it's something that just turns out to be 7. So in my quadratic formula, that's plus and minus 7. Okay, now this part is the opposite, so that's -5. And then that's 3 times 2, okay? Which really, 3 times 2 is 6. So the way I figure this out, okay, all right, and really that's all of the real length you need to get to, but it's going to be 2 divided by 6, which if you divide 2 divided by 6, you get this. So that's -5 plus 7. -5 minus 7 is -12 divided by 6, which is going to be -2. All right, wait, hold on. I think there's some kind of issue here. Oh, 2a. No, that's right. 3. All right, let me make sure I put in that right. Okay, let me make sure. Let me go back to my equa stuff. Polynomial, degree 2. Ooh, whoops. I put a 3. I'm sorry. All right, and let me hit solve. I'm sorry. That's 1/3 of -2. So that's one reason why you should try to put stuff in. I didn't realize that I had typed the wrong thing in there. So that is 1/3 and x equals -2. Sorry about that. I guess I hit the extra button. So that's the only bad part is you got to double check that. So using both is a good example. Okay. So let's go to this one. It says we can look at the solution 2 ways. You solve using the quadratic formula. Now to confirm my answer, I'm going to do 2, 11, and 5. Okay. And if I hit solve, all right, I get an answer of x equals -1/2. And I get an answer of x equals -5. All right. Once again, if I want to use the quadratic formula, okay, I'm going to do the b squared part first. All right. I'm going to do the b squared part first. So I'm doing 2 for alpha a. I'm doing 11 for alpha b. I'm doing 5 for alpha c. All right, and that's alpha b squared minus 4 alpha a alpha c. Okay, so I got 81. Square root of 81. Okay, all right, well, square root of 81 is going to be, square root of 81 is going to be 9. So what I have here is got plus and minus 9. Okay, that's going to be opposite, so -11. 2 times 2. Okay. So once again, that's -11 plus 9, which is -2. And I'm going to divide that by, this is really 4, right? So that is -1/2. -11 minus 9 is -20 divided by 4, which is -5. So if you guys show the work, confirm both. Now solve by graphing. All they want you to do here, if these are the zeros, 1, 2, 3, 4, and 5, go ahead and graph there. And -1/2, graph there. All right, and all you got to do is put a little graph through those points. Explain why you might choose a certain method, graphing, factoring, square roots. I think the answer to here is whichever is easier and faster. Okay? Sometimes graphing it with your calculator is an easy situation. I mean, I can do all of these in the calculator if I wanted to. I mean, I can go to menu and I can go to graph and I can type all this in. Okay? I can type in 2x squared, right, plus 11x, plus 5. I can draw it, and I can hit G solve root, and I can find both the roots. That doesn't change, okay? Okay, and that's it. That's my starting point. So here's the key thing. We'll get back to this to finish. To go from roots to factors, all right? Roots, solutions, zeros, intercepts, those with the equal signs. You get rid of the equal sign, change the sign. Move any fraction, okay? If you need to get to the equation, use the boxes to multiply, okay? If you're given the equation, okay, for instance, this one would be like 2x squared, all All right, minus 14 plus 5, minus 9x, minus 35, okay, I believe. Minus 14, yeah. So if you need to go back, you factor to get to the factors. And then to convert them back, change the sign, solve for x. Okay? That vocabulary is so crucial. If you can get that, you will do very well.